Dear students, for today let us discuss about Cauchy integral formula. For this we draw a circle C which is a closed contour and Z0 is at any point inside this contour C. Then this formula states that if f of z is analytic within and on a closed contour C and Z0 is any point interior to C, then f of Z0 is equal to 1 by twice pi I integration over the closed curve C f of z divided by z minus Z0 dz, where the integral is taken in the positive sense around C. To prove this formula, let us draw a small circle C0 with center Z0 and radius R0 lying entirely within C. Now consider a function fz z minus Z0 which is analytic in the region between C and C0, and therefore by Cauchy integral theorem for multi-connected region we have this integration over C f of z divided by z minus Z0 dz is equal to integration over C0 f of z divided by z minus Z0 dz. Here this Cauchy integral theorem for multi-connected region, we have already known it. There are two regions. One is simple connected region and another is multi-connected region. Simple connected region means it can be shrunk into a point. But in case of multi-connected region, this region cannot be shrunk to a point. There will be some hole. For this case, we have this, inside this C, there is a whole circle C0. Then this is equal to integration over C0 f of z minus f of Z0 plus f of z minus Z0 dz, and this is again equal to integration over C0 f of z minus f of Z0 z minus Z0 dz plus integration over C0 f of z minus Z0, this is of Z0 and dz. That is, this can be split into two integral, and for this is of equation 1. Then let us consider the circle C0. This z minus Z0 which is equal to R0. Then this z is equal to z minus Z0 which will be equal to R0 e to the power I theta. Z is equal to Z0 plus R0 e to the power I theta. And differentiating this, we have with respect to theta, we get d of z is equal to R0 I e to the power I theta d theta. So now considering the first part of the left hand side of 1, that is integration over C naught f of z minus f of z naught divided by z minus z naught dz, and this is equal to integration over C naught, and substituting this value of z, f of, instead of z we can write it as z naught plus r naught e to the power I theta, and minus f of z naught divided by this z minus z naught is equal to r naught e to the power I theta, and this dz is equal to r naught I e to the power I theta d theta. Then this can be cancelled out, and for this case this r naught, which is tends to 0, that is in the circle C naught this r naught tends to 0, then this term equal to 0, and this f of z naught minus f of z naught cancel out, and this term becomes 0. And for the second term, integration C naught f of z naught z minus z naught dz, which is equal to integration over this f of z naught remain as it is, and z minus z naught is equal to r naught e to the power I theta, and dz is equal to r naught I e to the power I theta d theta. Then for this case also it can be cancelled out, and this is all, and for this C naught is for dz, then we convert this integrate to theta. So for the circle, the lower it is of 0 to twice pi, the limit of this circle is 0 to twice pi. So this is equal to integration over 0 to twice pi f of z naught I d theta. So this is equal to I f of z naught integration over 0 to twice pi d theta. This is equal to I f of z naught integration over the theta limit is 0 to twice pi, so it becomes theta, and by putting this limit it comes out to be twice pi. So this is equal to twice pi I f of z naught. Now substituting these values, these two values in 1, that is integration over C f of z z minus z naught dz, which is equal to twice pi I f of z naught. Then therefore f of z naught is equal to 1 by twice pi integration over c f of z minus z naught dz. So hence proof. Now let us find out the derivatives of the analytic function by using this Cauchy integral formula. So from Cauchy integral formula we have f of z naught is equal to 1 by twice pi I integration over c f of z minus z naught dz. So differentiating with respect to z naught, we have this f of prime z naught, this is equal to 1 by twice pi I, and for differentiating this term it becomes z minus z naught square dz. Then again similarly we can find out this f double prime z naught also and f triple prime z naught also, and so on. And finally we find out this f of n z naught, where n is 1, 2, 3, etc. That's all. So dear students, we have discussed about Cauchy integral formula and derivatives of analytic function. For any queries, please visit our college website. Thank you.